Inside the massive data centers being built by today's major technology companies, the physical footprint is truly staggering. Millions of square feet are dedicated entirely to housing the hardware required to process artificial intelligence workloads. For investors watching this build-out, the sheer scale is a source of anxiety. The major cloud providers, the hyperscalers, are spending tens of billions of dollars on infrastructure, and their free cash flows are compressing under the weight of these capital expenditures. The fear driving this anxiety relies on a specific assumption about how artificial intelligence operates. Market consensus suggests that as AI usage grows, computing costs will scale in a straight, linear line, creating a financial burden that these companies cannot sustain. But according to new research from Goldman Sachs, that linear projection misreads where the technology is heading. A distinct shift in AI computing architecture is about to sever the link between rising usage and unsustainable costs. The catalyst for this shift is the transition away from passive chatbots that wait for a prompt and toward autonomous AI agents that operate continuously in the background. This animation tracks the projected impact of those autonomous agents on global computing volume. Daily AI queries are forecast to grow from roughly 5 billion today to 23 billion by 2030. That demand drives a 24-fold increase in global computing volume, pushing total consumption to 120 quadrillion data units processed every single month. This volume surge, when paired with falling hardware costs, forms the basis of the Goldman Sachs forecast, a structural shift in profitability they call a gross margin inflection. If the modeling is accurate, these capital expenditures represent the fixed costs necessary to support a significant expansion in operating cash flow. To understand how tech companies actually generate revenue from this hardware, we have to look at the foundational unit of artificial intelligence economics, the token. Tokens are units of compute, fractions of data that a large language model processes. This diagram illustrates how token consumption works under current models. On the left, a standard chatbot relies on intermittent request and response transactions. The model sits idle, a user asks a question, processes a batch of tokens, and delivers a single output. An agent operates as an autonomous loop, monitoring an environment and calling upon specific software tools to complete a multi-step objective. Once the initial action is taken, the agent checks its own work, corrects errors, and iterates on the next step. It repeats this continuous loop without any human intervention. That repeating loop drives compute demand upward. Goldman Sachs calculates that applying agentic architecture to a standard query acts as a 10 to 50-fold multiplier on token consumption. The math scales rapidly. A single autonomous agent deployed to write software code can independently consume 7 million tokens in a single day. A user input no longer equals a single isolated compute action. It triggers an autonomous cascade that permanently raises the baseline volume of computing demand across the entire data center ecosystem. The initial wave of this volume expansion is originating in the consumer sector. Routine online queries are shifting away from traditional search engine indexing and moving toward large language model processing. Those queries are evolving into smartphone takeover agents. These tools operate constantly in the background, filtering junk mail, organizing inbox priorities, and independently booking complex travel logistics. While consumer agents generate steady usage, enterprise applications are the high-density engine for future token volume. Businesses are moving past using AI for simple text summarization and are deploying it to automate highly regulated, multi-step workflows. This includes executing complete call center simulations and integrating autonomous agents directly into production environments to write, test, and document software code.
For the hyperscalers providing the infrastructure, this represents a structural change in the market. Enterprise AI integration replaces the intermittent output of human labor with the continuous, uninterrupted consumption of high-volume computing power. To handle that continuous consumption profitably, the hardware has to keep pace. The math comes down to the specialized semiconductor chips powering the physical servers. Operating a model at scale requires managing inference cost, the financial expense incurred by a data center every time a trained AI model generates a result. This chart maps the economics of inference. While the curve for token demand is rising exponentially, the physical cost of processing each individual token is decaying by roughly 60 to 70% every single year. Semiconductor manufacturers achieve these rapid cost reductions through both raw chip efficiency and broad architectural improvements across the entire data center network. Goldman Sachs defines this intersection as the margin inflection point. At this juncture, the volume of token consumption begins to outpace the falling cost of processing them. The widening gap between revenue and physical cost translates into cash. This expanding gross margin provides hyperscalers with the operating cash flow necessary to offset the tens of billions they spent building the infrastructure in the first place. Rising AI usage is not a cost burden. Because inference costs are dropping faster than token prices, surging volume acts as a catalyst for asymmetric profitability for the firms that control the hardware. That profitability will not materialize immediately. The transition relies on physical supply chains that cannot scale at the speed of software development. This timeline maps the immediate structural bottleneck. Building a semiconductor plant takes 3 years. Because the industry planned capacity for chatbots rather than high-volume agents, data centers enter a semiconductor shortage expected to last for 12 to 18 months. On the software side, corporate governance acts as a strict speed limit. Enterprise agent deployment requires exhaustive testing, regulatory compliance, and system documentation before going live. As a result, Goldman Sachs forecasts that only 12% of knowledge workers will actively use agentic AI by 2030, growing to 37% by 2040. Small and medium-sized businesses, which lack the resources of major tech firms, face even steeper hurdles regarding system integration, pushing adoption into a decades-long tail. The shift toward an agent-driven economy is gated by hard limits. It relies entirely on the physical capacity of silicon foundries and the risk management protocols of corporate IT departments. Viewing the current wave of tech capital expenditure as permanent cash flow destruction misreads the underlying mechanics of the AI industry. That perspective measures the cost of buildings without factoring in the collapsing unit cost of processing data, or the compounding volume generated by autonomous software loops. As the cost of inference falls and the utility of autonomous agents rises, the total addressable market for the global software industry expands. The rollout will still be uneven. Real-time, latency-dependent tasks, like live voice customer service, currently remain cheaper for human workers to execute than autonomous models. The physical infrastructure will dictate the market winners. The hardware manufacturers and cloud providers positioned to weather the current 18-month chip shortage will capture the lion's share of the margin inflection. The adoption of artificial intelligence infrastructure is a highly staggered process. But the underlying math, the intersection of exponential volume and deflating cost, is structured to reward hyperscalers with unprecedented cash flow generation over the next decade.